These components basically used to absorb, to store energy, but they are not used in supplying of energy. So that's the basic difference between active and passive components. Lengthier side must always be the positive terminal and the shortest terminal is always the negative side. What do you mean by open circuit? When there is no current flowing through a circuit, we'll call it as open circuit. Hello everyone, welcome to session 4 of chapter 3 Current Electricity. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in understanding any circuits, knowing about its component is very important. So few components we will oftenly use in the electronic circuits. So regarding that, we will have a brief introduction. So the electronic components are mainly classified into two categories. One is active component, the other one is the passive component. What is the major difference between the active component and the passive component? So active components are able to supply the electrical energy, or so we can amplify the energy with the help of these components. So we'll call it as active components. Basically, they are used to supply the energy to the circuit, and these components also helps us to amplify the energy from one form to another form. Now, how the passive components are different from active components in this category? Passive components are nothing but the components which are used to absorb, store or dissipate energy. These components basically used to absorb, to store energy, but they are not used in supplying of energy. So that's the basic difference between active and passive components. Few examples what we can give to understand what are active components. They are cells, batteries, diodes, transistors, and these are the components which are used to supply the energy to electrical circuits. But in case of passive components, we all know it is a resistor, a capacitor and inductors. Capacitors, in the last chapter we have studied energy stored in a capacitor or parallel plate capacitors. So these both plates can be used to store the charges. So these are the components basically used to store or to dissipate or to absorb the energy. So in this chapter, we have to know about the cell. What is a cell? What is a battery? Resistor, capacitor we have already studied. So what is a cell basically? It is one of the active electronic component. Why am I saying active electronic component? Because cell is used to supply the energy. One of the active electronic component which supplies electrical energy to the circuits. The circuit symbol of cell is given by this. It consists of two terminals, or even if we consider an electrolytic cell, it consists of two electrodes, anode and cathode. So here we have a positive terminal and a negative terminal. The two plates of capacitors are parallel. When you compare the capacitor circuit symbol with cell, two terminals or the two plates what we consider in capacitor, they are parallel to each other. But in case of cell, you can just see the variation between this. The positive terminal of a cell is quite lengthier, or the length of the positive terminal symbolically is quite lengthier when compared to the negative terminal. These two are not equal in their heights. So they are not parallel exactly. And this is the basic circuit diagram of a cell. So what is battery then? Now we have understood what is cell. So battery is nothing but a combination of cell. It can also be a single cell, but generally it is denoted as a combination of cells. Circuit symbol of battery, you can see here positive, negative, positive, negative. We have combined two cells here. So when we combine number of cells, we'll call it as a battery. The lengthier side must always be the positive terminal and the shortest terminal is always the negative side. We are discussing about the cells. We need to understand the properties of cells. So with the help of cell, we can just maintain the potential between the terminals of a conductor. EMF also develops, and also these cells has also got some internal resistance. So let us know about these terms now. So this is a basic electrolytic cell. Why do we call it as electrolytic cell? Because it consists of electrolyte solution, and it has got two electrodes named as plus P and minus N. I am calling it as one is an anode and the other one is a cathode. So these electrodes are immersed in an electrolytic solution. So what happens when these electrodes are immersed in it? These electrodes exchange their charges with the electrolytic solution. As a result of this, two electrodes will also gain some potential, and we'll name it as potential V plus and minus V minus, that is negative potential, they are of opposite charge, and these two potentials are greater than 0 or it may be equal to 0. So now we know what are the potentials due to a positive electrode, due to a negative electrode, that is V plus and minus V minus. Now we have to calculate the potential difference between these two electrodes. The potential difference between two electrodes can be calculated as V is equal to V plus minus of minus V minus, which is equal to V plus plus V minus, that is positive potential plus negative potential, and that is called as potential difference V. So this potential difference is greater than 0 and it is called as electromotive force. In short, we'll call it as EMF. So now we have clearly understood what is a cell. It is a simple device which is used to supply the electrical energy, or to maintain a steady current we use cell in a circuit. And electromotive force, that is called as EMF. It is defined as the maximum potential difference between the electrodes when it is an open circuit. What do you mean by open circuit? When there is no current flowing through a circuit, we'll call it as open circuit. Now let us understand terminal potential difference. What is the meaning of terminal potential difference? So this name only defining what it is defined as the potential difference between two electrodes of cell when it is in closed condition, when it is in closed circuit. What do you mean by closed circuit? When the current is drawn through a circuit, we'll call it as a closed circuit. Then no current will flow through the circuit. Then it is an open circuit condition. So now we will discuss about internal resistance. Another important terminology in understanding the circuits, that is internal resistance. The meaning of internal resistance is nothing but, so the resistance offered by the electrolyte is called as internal resistance. Now after knowing all these important definitions, let us move to the next topic, that is expression for current in a simple circuit. Let us write an expression for current with the help of simple circuit. Let us consider a simple circuit with a resistor R. It is connected to a cell. So this is V, which means the potential across the resistance R, and V dash is potential across the ends of a cell. So it's a positive terminal, negative terminal. So this cell has also got some internal resistance R. So the EMF due to this is E. This is a simple circuit. So let us now derive the expression for current. So potential difference across R is given by V is equal to IR, that is from Ohm's law, because if it is maintained with a potential, which means current is flowing from a positive terminal and it is flowing through a circuit. So with the help of Ohm's law, the potential difference across the ends R can be V is equal to IR. Similarly, the potential difference across the internal resistance small r can be V dash is equal to I into small r. So what is V dash? That's a new potential, or the potential across the cell which has got internal resistance small r, and hence it is V dash is equal to I into r. We know by the definition of EMF of cell, EMF is equal to sum of the potentials through the circuit, that is V plus V dash. What is V? According to our equation, it is I into r, and V dash is I into small r. So in both these cases, I is common. I have taken it outside the bracket, and the remaining terms are r plus small r. Here we need the expression for current, and current is denoted by I, and from this expression we can write I is equal to E divided by r plus r, where E is EMF of the cell, capital R is the resistance of the resistor connected, and small r is the internal resistance. Let us now understand what if these two cells are combined together. What happens to EMF when the cells are in combination? So we can combine the cells in two ways. One is in series combination, the other one is parallel combination. So let us now derive an expression for EMF of a cell and internal resistance of cell when they are connected in series. You can observe here I have considered two cells connected in series. Now E1 is the EMF of first cell, E2 is the EMF of second cell, I is the current flowing through the circuit. R1 and R2 are the internal resistances of cell 1 and cell 2 respectively. Here potential at A is VA, potential at point B is VB, potential at point C is VC. So now this combination is compared with, or it is replaced by a single cell with an equivalent capacitance. Then the circuit diagram is, here we have considered a single cell of capacitance E equivalent, which is having a internal resistance R equivalent, and I is current flowing through the circuit. So the potential across the first cell is given by VAB is equal to E1 minus IR1, because you know here the 2 points due to first cell is VA and VB, that is the potential at point A and potential at point B. So according to this, we can write the potential across the first cell is VAB is equal to E1 minus IR1 from the expression V is equal to E minus IR, which we have already derived. Now similarly, we can write the potential across the second cell, that is, you can see here the points across the second cell is B and C, and VB is the potential due to B and VC is the potential at point C. Now VBC is equal to E2 minus IR2, that is across the second cell the potential is given as VBC is equal to E2 minus IR2. Now how to get the total potential difference between the points A and C? We have combined two cells. Between these two extremes ends we have to find the potential difference. How to find the potential? By taking the sum of potentials of two cells individually, that is VAC is equal to VAB plus VBC. Now VAC is equal to, what is VAB? It is E1 minus IR1 and VBC is E2 minus IR2. Now from this we can write E1 plus V2 minus I of R1 plus R2. That is my equation 1. Now let us write the same for the equivalent circuit. We know the equation for potential is V is equal to E minus I into R. Now for equivalent circuit it is E equivalent minus I into R equivalent. That is my equation 2. Now by comparing equations 1 and 2, in the place of E equivalent I have E1 plus E2 in the previous expression. In the place of R equivalent we have R1 plus R2. So for n number of cells, if we combine n number of cells, then equivalent EMF or E equivalent will be E1 plus E2 plus and so on up to n number of cells, that is En. And similarly, the internal resistance equivalent, R equivalent is equal to R1 plus R2 plus and so on up to Rn. So this is the expression for EMF and internal resistance when the cells are combined in series. So in today's session, we have learned what is a cell, what is a battery, and how can we group this cell. How can we write the expression for EMF and internal resistance by combining these two cells in series? So in the next session, let us learn what is the expression for EMF and internal resistance when two cells are combined parallelly. Until then, keep learning all of you. See you all in the next session. Thank you.